All right, let's look at thermodynamics a little bit. So far you've got the quantity of energy absorbed or released is equal to the mass times the specific heat capacity, which is how much energy you have to put into a material before it changes or remove from a material to change it 1 degree Celsius or 1 degree Kelvin. Okay, and then you multiply that times the change in temperature, which is the final temperature minus the initial temperature. One of the things that you can do with this is you can identify things like the specific heat of materials or look for final temperature, predict final temperatures if you know some things like that. So if you have two things, it's usually like this. You have a cube of some sort of metal and you drop it into some water and then you wait for the temperatures to equalize so their final temperature is the same. And then you can tell some things about that. One of the things you need to realize is that whenever you put a hot object into cold water, the temperature of the hot object decreases and the temperature of the cold water increases until they are exactly the same temperature and the same amount of energy is transferred from one into the other one. So in this case, we have a hot piece of metal, we put it in water. The metal transfers the energy from the block into the water. So this one loses energy and this one gains energy until they reach equilibrium. We're working on the assumption that these are the same. So your net value would be Q2 minus Q1 equals 0. And when we reorganize that algebraically, we end up with these two are equivalent. So notice that if we know that Q1 and Q2 are exactly the same thing, then we run into this formula. And I like to put the hot object on the left just to keep it where I don't have to move the signs as much. But you end up with a formula kind of like this. And I hope I didn't miss a sign in here somewhere. So you may have to check my algebra. But look at this. We have the mass times the specific heat. The final temperature and the initial temperature of the hot object, which is usually a block of metal. And then the water that we're putting it in, which is usually cold, and it increases temperature. So we have the mass of the water times the specific heat of the water. Times the difference between the final temperature and the initial temperature. One thing to recognize, the final temperature for both of these is the same. So we're calling it TF instead of 1 and 2. When you do that, then you can start doing some things like distributing this product into the parentheses, and that's going to let us move things around more conveniently. So I distributed the M times C into the parentheses here and here. And then we can start doing some things like this. We can get the final temperatures on one side and the initial temperatures on the other side. And then we can distribute or factor out the TF from the left side of our equation. And then we can move this subtraction to the other side of the equation by dividing it. So you can calculate the final temperature like this. The key to this is getting your formula to this state, and then you can solve for any of these factors, like the initial temperature of one of them, the final temperature of one of them, the specific heat of one of them. So that's some things you can do once you get it to this point here. I hope you find this helpful, and let me know if you have further questions.